All right, let's find this problem real quick. Let's find this one right here. As you can see, it is number 4 from your sheet. So let's go over how to do this one on Hess's law. So I think this one might give us the most trouble. So real quick, laws or rules to doing Hess's law. Remember, all the intermediate steps will get us to that final state function place. So in this case, we know what our balanced equation is. We see it right here. We have all those intermediate steps with their change in enthalpies, so we can use them to tally up and give us our final answer. We may need to flip them. We may need to multiply or divide them to get the right amounts. And when we do that, we have to change sign, and we have to adjust for our change. So if it's times 2, we will have to multiply our enthalpy and all our coefficients by 2. So what I always do is step 1 is I locate everything that I need from the final balanced equation in my intermediate steps. So in equation 1 here, what in equation 1 do I need for my final answer? HCl. They're both right here. So this one has an HCl. And NaCl. So we have both of those. Equation 2 has what that I need for my final answer? The NaNO2. Equation 3 doesn't have anything I need for my final answer, but will be important because it's probably going to be an equation that removes a lot of those intermediate compounds or steps that we don't need. And then equation 4 here shows me HNO2, which is what I need for my final equation. So if I was starting it, I always locate what I need, because that's going to tell me if I need to flip. It's also going to tell me if I need to multiply or divide. So let's start this off with reaction 1. So reaction 1, are my 2 things in reaction 1 that I need in the correct place, reactant product? No, they're not. HCl is a product, and I need it to be a reactant. NaCl is a reactant, I need it to be a product. So I'm going to have to flip this equation. Also, am I in the right quantities? We're going to have to cut it in half. HCl in the reaction is in 2. NaCl is also in 2. Whereas in the balanced final equation, I need them to be in 1. So I'm going to need to flip it and divide by 2. So let's do that. So if I flip it, I will have HCl first, which will be a gas. And I will have 1/2 Na2O. And that is going to make NaCl and 1/2 H2O. Now, when I flip it, what do I need to do to my change in enthalpy sign? It needs to also flip, yes. So delta H here is a positive 507, so it needs to become a negative 507. And then we also need to divide it in half because we divided the entire thing in half. So 507 divided by 2 will give me 253.5, and it's got to be negative. And again, it's got to be negative because it was positive before. I reversed the equation, so I need to reverse the sign. I cut it in half. I need to cut that value in half. All right, let's add equation 2. Equation 2 gives us NaNO2. Is NaNO2 in the correct position for our final equation? No. We're going to have to flip it again. It is a product. I need it as a reactant. So I will be adding NaNO2. So for 2 here, I need to flip and cut it in 2, as you're saying. Because NaNO2 in the final balance equation is just 1. It is 2 in the reaction data they give you. So again, flip and divide by 2. So I will get NaNO2 as a solid, and it is going to decompose to give me 1/2 NO, 1/2 NO2, and 1/2 Na2O. Now, we flipped it, so its initial energy or enthalpy sign was negative. It needs to become what? Positive, because we flipped it. So 427 also needs to be cut in half, because we cut in half our entire reaction. So our new enthalpy change is a positive 213.5. Now, we can continue to add these reactions, but because we've done 2, we can kind of easily add up what we got, cancel what we know needs to be canceled, and see where we stand. So, let's do that. On my reactant side and my product side, do I have anything that is the same on both? Yeah, that 1/2 Na2O is on both sides. Because it is also a product and a reactant, I can get rid of it. And there's nothing else that's the same on both sides. So let's combine everything. Let's put all our reactants on one side, our products on the other. So I should end up right now with HCl plus NaNO2 is going to create NaCl plus 1/2 H2O plus 1/2 NO plus 1/2 NO2. So that's where we're at so far. Now, we can also get our enthalpy change difference. I can just add those two together. So negative 253.5 plus 213.5 should give me an enthalpy change currently at minus 40 kilojoules. So that means at this point we're releasing 40 kilojoules of energy. Okay, equation 3 or reaction 3 or step 3 isn't going to give us anything towards our final equation, but we can definitely use it to get rid of some stuff. We know we don't want this H2O, we don't want this NO, and we don't want this NO2. So, I need to do what with this equation to get rid of some stuff? Do I need to leave it the same? Do I need to cut it in half, or do I need to flip it? Yeah, I can leave it the same. I have NO as a reactant, NO2 as a reactant. NO and NO2 are over here. So we can use this to get rid of them, because we know we don't want them in our final balanced equation, because they're not there. So for 3, I'm going to leave it the same, so I won't change my sign. But what am I going to have to do to the equation? Yeah, I'm just going to be dividing this one by 2. I'm cutting it in half. Because, again, I need half NO, half NO2. So I need to cut this one in half. So for 3 here, it's going to stay the same. I'm going to have 1/2 NO as a gas plus 1/2 NO2 as a gas. And that's now going to create 2 new things for me, N2O as a gas, and they're also halves, 1/2 O2 as a gas. My change in enthalpy was negative 43. I need to cut that in half, so it's going to be negative 21.5 kilojoules. It's still negative, remember, because we didn't flip it. So what do I have that's a product and is also a reactant that we can cancel? The 1/2 NO and the 1/2 NO2. So if I rewrite it again, I have HCl plus NaNO2. It is going to make NaCl 1/2 H2O 1/2 N2O and 1/2 O2. And our change in enthalpy is going to be negative 40 plus negative 21.5, which is negative 61.5. Question?
Is this the type of question that would be on a short answer or a multiple choice?
I would see this more as a short answer because you have to do these intermediate steps.
Okay, do you have to show your steps? Like on the test, would you have to, or would you just have to show an
It
answer?
depends on if they give one. I don't know. I have not seen one directly, but they definitely have you do change in enthalpy questions.
Would they tell you though if you have to, if it's a short answer, like if you have to show the step, if you have to show the step?
If you saw this as a short answer question, it would be written like you see above, or it'll be written like you'll see in one in a second, where you would have to logically come to the conclusion that it's going to be a Hess's law problem. You go, oh, I know I need to do those intermediate steps. Or they would just give you all the intermediate steps and say, why does this answer make sense? And that would be more of a multiple choice question. Remember, it's a timed test, so they will definitely make sure you are at that time. They're not going to this takes a long time to really step through. Okay, we have one reaction left. So this one reaction that's left, better do a good job at getting rid of the stuff we don't need, or else we did this wrong. So it is going to give us HNO2. That HNO2 in the reaction is a reactant, but I need it in what space? I need it as a product. So I'm going to, again, have to flip, and I'm going to have to divide it by 2. Because it's got 2 HNO2, I only need 1 HNO2. So for reaction 4, it is going to be 1/2 N2O plus 1/2 O2 plus 1/2 H2O is going to give me 1 HNO2 as a liquid. And again, my change in enthalpy is 34. I flipped it, so it needs to be negative 34. And then I need to cut 34 in half, so it should be negative 17. So hopefully, when we cancel everything, we have our final balanced equation. I have 1/2 H2O on both sides. I have 1/2 O2 on both sides. I have 1/2 N2O on both sides. So the only stuff I have left is HCl, NaNO2, HNO2, and NaCl. Does that match the equation they wanted me to check from the beginning? Yes. So we used all those intermediate steps to get to where we wanted to be. And we know all the enthalpy changes that went with it, so our final enthalpy change should match what our answer should be. So in this case, our final enthalpy change will equal the negative 61.5 plus a negative 17. So our final answer should be negative 78.5 kilojoules. So that means for this reaction, when it occurs, we are going to have 78.5 kilojoules of energy released exothermically from the reaction. This equation, there's not a good way to check and see because there's 2 products. If it was just a smaller one where you were doing like a simple formation equation or combination synthesis, you could look up a heat of formation or a enthalpy of formation value, and they should match.